Okay, so this is right-hand rule for moving charges. It is basically it's going to be right-hand rule if a charge is entering a uniform magnetic field. So what we're going to have to recognize is that before is that the magnetic field, the direction of the particle, and the magnetic force are always going to be perpendicular to each other. They're never going to be on the same plane. It always has to be perpendicular. As we've seen here, that's why we have the 3D plane. Now there are certain rules that we're going to have, right? So the force always going to be perpendicular. Force is always going to be perpendicular to the motion of the particle. And there must be a velocity for a magnetic force to exist. These are two basic rules that are going to have to be very important, and this comes basically from the equation magnetic force equals BVQ, or B is going to be the magnetic field, little v is going to be the velocity, and Q is going to be the charge. So it's always going to be perpendicular to the motion, and there must be a velocity for the magnetic force to exist. So in a uniform magnetic field, right, if it's always perpendicular to the motion, then it's not gonna do actual work on the particle. Now what do I mean by that? As it's perpendicular, remember, for work to be done, the force has to act on the same direction of motion. As it's perpendicular to the direction of motion, there is no work done. So what does that mean? That means the kinetic energy of the particle does not change if a force is applied in a uniform magnetic field. That means that's because there is no work done on the charge or particle. And that also means, we're gonna look at it later, that the particle is going to take a circular path. As the force acts perpendicular to it, it's gonna, if you recall from rotation, it's gonna act as a centripetal force. It's gonna point towards the center, so it's gonna go around in a circle, as we see here. So with those basic guidelines out of the way, let's look at the right-hand rule. So the right-hand rule goes like this: your thumb is going to point in the direction of motion of the particle or charge. Then, as if you were pointing a gun almost, your other two fingers are going to be the direction of the magnetic field and the direction of the magnetic force. So thumb's going to be the direction of motion, your index finger is going to be the direction of the magnetic field, and it's going to be perpendicular. And your middle finger, so you're not going to extend it in the same direction as your index finger, you're going to pointing towards, so that it's perpendicular. So let's say you just you're holding a let's say you're kind of holding you're representing a gun with your fingers basically. So your thumbs up, then your index fingers going into the screen. So then your middle finger is gonna go to the side to make so that it's all perpendicular as we can see here. So this is perpendicular over here, and this is actually gonna go towards the other side. Same as here, you see it makes a little L, and then your middle finger is gonna go, it's not gonna go in the same direction as your index finger, it's gonna go kind of towards the center of your, towards another side, so that it's all perpendicular to each other basically. So let's try the right hand rule. On positive charges, you're always gonna use your right hand. On negative charges, you're gonna use your left hand. Okay, so let's try this one. So the first thing you gotta do is recognize the direction of the magnetic field and the motion. So we can say it's into the page, and the motion is to the, sorry about that, it's gonna be to the right. So your thumb's gonna be to the right, and your index finger is gonna point into the page. Now if you're gonna now lift your middle finger, always maintain it perpendicular to both your thumb and index finger, as shown on the hands. You know it's gonna point up. That means that the force is gonna be up. As you saw, it's always gonna be perpendicular to the motion, right? So as the motion is moving right, it's perpendicular to be up. But when it's here, its motion is gonna be up, right? So we do the same thing. It's going up. You point your index finger into the page with your right hand because it's a positive charge, and then you extend your middle finger, sorry, your index finger into the page, your thumb up because it's moving, then you extend your index finger and you're gonna know it's gonna point left. So the force here is left. So that's why it creates a circle, because it's always gonna be perpendicular to the motion. So here, if let's say it's like that, it's gonna point inwards, right? And you know that if it's pointing towards the center, it's gonna be a centripetal force, mv squared over r, which causes a circular motion. So that's why it's always gonna be a circle. Now let's do it with our left hand, right? So left hand, we're gonna put our thumb into the right because it's going into the right. That's our thumb. Then it's gonna go into the page. So our index finger, it's gonna go into the page, point into the page, and if we extend our middle finger, it's gonna go down. So our force is gonna be down, which is, and now you see why it goes that way. It goes down, and the positive charge goes up. It's gonna go down. So that's why they take those motions. So let's do another one over here. Let's say this is a positive charge. Just imagine that's a positive charge. And these are the magnetic field, which is always going to be like B and a vector symbol. So these lines are the magnetic field. So that's right hand rule, okay? Let's spread the right hand rule. First, thumb. It's going down. It's gonna be a positive charge, so you use your right hand, so it's going down. Then your index finger, as you're gonna point it in the direction of the lines, because that's the direction of the magnetic field, and then you're gonna stretch out your middle finger so that it's perpendicular to both, and you're gonna notice that it's pretty much pointing towards you or out of the page. So actually the force is going to be out of the page. It's going to be out of the page. And the force can be up, down, out of the page, in, out of the page. Doesn't matter. It can be in either direction. So now let's try it with. I'll let you do this by yourself. Let's do a negative charge. And this is the magnetic field. Okay, so you can do this. If it's confusing how I explain the right-hand rule, you could always look at this drawing and this drawing, how all your fingers are going perpendicular to each other, and kind of practice that form. And it's a weird form, but kind of memorize it, how it's going to be. And your middle finger is always going to point. It's always going to be kind of pointing towards where your palm is pointing. Your index is going to be stretched out, and your thumb is going to be making an L with your index. And when where your palm's pointing, so your palm here is pointing outward, so that's going to be the direction of your middle finger. So just recognize yourself. You can always look at more images, and then you can always come back if you feel uncomfortable and do these problems again and go over them with me. So let's do that problem. So if you want to pause the video and do it, go ahead. But so it's a negative charge, right? So we're gonna use our left hand, and it's moving down. So we're gonna point down our thumb. Our next move is the direction of the magnetic field. So it's actually gonna go to the right. So our index finger is gonna go to the right. Then we stretched out our middle finger in kind of the same direction of our palms pointing, and we see that it's going into the page. So the force is going to be into the page. It's going to be into the page. So that was the right hand rule for moving charges. That's basically 3 right-hand rules explained. Right-hand rule for solenoids, Maxwell's right-hand rule, if you want to memorize those names to help you remember which one's which, and then right-hand rule for moving charges. Now you will use right hand and left hand for moving charges depending on the sign of your charge or particle, and then you will use you will generally use your right hand on the other two. So thanks for watching. If you need any further clarification stuff, just tell us, and we'll hope to see you on another video. Thank you.